Hello, wonderful people, and welcome back to another talk at Web Components Remote Conf. With me now is Chris Lorenzo. Chris, welcome.
Hi, thank you for having me.
And you're going to talk about simplifying with Google Polymer. So I'm going to get out of the way and let you have at it.
Thank you. So again, this talk is simplifying with Google Polymer. My name is Chris Lorenzo. I'm a senior principal engineer at Comcast. So for those who don't know Comcast or outside of the US, it's the largest cable TV and internet provider in the US. It's a Fortune 50 company. We have 30 million customers. We also own NBC Universal, which again, if you're outside of the US, you probably don't know too much of their content, but they're a big network here in the US. And our company has about 500 components right now, all Polymer. A little bit more about me. I've been married for 5 years, my beautiful wife. I've been with Comcast for 9 years, going on my 10th year. And I've been a front-end developer for 16 years now. And I have a son and a daughter who are both adorable. So that's my son Theo and our 2-month-old Josie. And again, I'm from the United States, Philadelphia area. For those who don't know, I always like to start with a little geography. Most people are familiar with where New York City is. That's that little island right there. And they all know California is this big place over there on the other side. Philadelphia is about 2.5 hours, maybe 2 hours drive to New York City. Once you get to New York City, then it's like 30 minutes to get in. And I work in this great building called the Comcast Center. This is the Philadelphia skyline. The building on the left there is the current Comcast Center. This new building is actually a rendering, which is currently under construction and should be done by early next year, I would say, and that's going to be the technology and product center that we're all going to be moving into. Great place to work. So some of the things that Comcast works on and my group works on, this is the Xfinity Portal. This is a Ruby on Rails app that gets about 1 million unique visitors a day. I'm not sure if that's an hour or a day, but it gets a lot of visitors. It's the main portal for our customers. Next, we have the My Account site. This is where our customers can go to pay their bill, check out their account information. This is an Angular application. We also have the Xfinity Home portal. So this is actually our first Google Polymer site, which we'll talk more about in a little bit. We have our latest Polymer site, XFi, which allows customers to control their internet settings, basically disable certain users on the network, set parental controls, etc. And of course, as a Comcast a network television cable provider, we have the X1 platform, which allows our customers to watch television on their TV or on their laptop or tablet, etc. The web version of this is also a Google Polymer site, which is really great. So before I get started on this talk, I just want to let you know I'm not going to go into too many details about Polymer. I've talked about that a lot of times before in the past. I have talks available on YouTube that you're more than welcome to check out, hopefully after this talk, so that I could finish this talk. So let's get started. This talk is broken up into 3 different sections, 3 acts as I like to call them. The first one is why I love Polymer, which is roughly 10 minutes. The next one is the Polymer experience, which is what we're doing at Comcast with Polymer. And then I'm going to talk for a few minutes about my vanilla component that I wrote. So let's get started. Act 1, why I love Polymer. And I want to talk a little bit about my coding journey and my experience as a developer. And I have this notion of programming foo level. And when you start off as a developer, in the beginning, you're learning syntax and you're learning languages, and your foo level quickly increases because you first understand how to do a for loop and if statements, and you become very powerful very quickly. But over time, you kind of plateau. And there's reasons for that. For me, it was because I worked on the same application and I was maintaining it for a couple years, and you don't really learn new technologies, and you kind of get stale. But you get to this point where you're also wondering not how to use the language, but you have these bigger questions of how do I build an app? And that's really difficult. And some other questions are like, how do I maintain an app? Again, I had one application where I was on the team for 5 years, and we had to maintain it and add new features all the time. And sometimes, like, the really hard questions in life are, which way should you go? And my son makes it really easy. He always says, that way. But as developers, we're constantly faced with choices of like, which framework, how should we build this, what should we do? And I can relate. It's really hard to like figure this out and know what to do. And that's why we're, in love with these frameworks. These new frameworks come out all the time, and they're very popular because they take some of these questions away from us, and they give us this path that as long as we are on this path, we should be good, and we should be able to implement something that's good. And of course, there's always some snow in the path that you kind of have to like get around, and you don't want to leave the path because as soon as you do that, it's dangerous outside of the path. And the problem with this is, as Andrew Ray sums up, no one knows how to structure a front-end application. I've worked in this industry for years, and best practices are never taught. Instead, libraries are taught, jQuery, Angular, Backbone. I mean, I've had examples of interviewing people who are Angular developers for a couple years, and they come in and I ask them to write some vanilla JavaScript, and they're like, well, can I do that as a directive? And I'm like, ooh. And even at Comcast, we fall into this problem too. We have this new Xfinity speed test beta site, and this is the entire site. You go there and it measures how fast your internet connection speed is. And it was written in Angular. And I just went, why? Why are we using this giant framework to write one single page? And so it's important for us as developers to increase our foo level. And for me, a couple years ago, when I started learning Polymer, that's when my foo level greatly increased. And for other developers, it doesn't have to be Polymer. It could be React or Angular or Vue.js or whichever framework or library you're using, as long as you understand why you're using it and why these frameworks are popular. So for React, I really love this quote. React is all about building reusable components. In fact, with React, the only thing you do is build components. Since they're so encapsulated, components make code reuse, testing, and separation of concerns easy. And for me, that was really my light bulb moment. When you understand the core concept of why these libraries and frameworks are so powerful. And I have a computer science major. Computer science is really tough. There's all these hard words that you hear in computer science all the time about encapsulation, composition, separation of concerns, decoupling, functional decomposition. And like, while all these words have a different meaning, like different nuances to them, they're kind of all saying the same thing, which is they really want you to decouple all the things. And the reason why you want to do that is because simplicity matters. There's this great talk by Rich Hickey where he describes your application like an elephant. And when you first start off building your app, you develop features really quickly, and you can build it up because it's easy to add new features in the beginning, but eventually your application grows up to be an elephant. And eventually you're asked by your product team to add this new feature, and you get in the room with all the developers and say, okay, how do we make the elephant move a little bit more forward? And it becomes really tough. And really what you want is you want a simple decoupled component system that are made of small blocks that you can easily add new features on top of, or pull it apart and add new blocks in between. And that's why I love Polymer, because Polymer and web components in general are all about building these little teeny tiny components. And you may be wondering, like, well, how is that any different than Vue.js or Angular or React? Because they're also all about building components. And the main difference is Polymer sprinkles a bit of sugar over the standard web components API, making it easier for you to get great results. I know that sounds like an infomercial, probably is. And that's the big difference, is this web components API spec. It basically allows you to write your own component tag. But there's more. Like the web component spec is actually 4 different specs. The first one being custom elements, the second templates, HTML imports, and shadow DOM. Custom elements is what gives you the ability to write your own tag. Templates allows you to put markup into the page with it being completely inert. HTML imports allows you to import an HTML document which contains CSS, JavaScript, and whatever else you want in there. And the shadow DOM allows you to completely encapsulate these components so that you don't have to worry about your CSS bleeding through and affecting other components on the page. And you can use each of these components or each of these specs individually of the others. And so here, it's 2017 now, and the great part is it has all these specs natively in the browser, which means Opera does. Firefox is currently developing all the specs except for HTML imports. I do want to say that HTML imports, doesn't seem to be going anywhere, so I'm actually trying to avoid using it for some of our components. But custom elements, Safari actually just said they're going to release it in the 10.1 version, and Shadow DOM is currently out in Safari 10, so it's in the wild. So that's great. As for Internet Explorer or Microsoft Edge browser, these are the #1 voted features for them to implement. And of course, being Microsoft, they always go for #4 and start implementing service workers for some reason. But eventually they'll catch up and they'll have this built into their browser as well. I also want to note that we at Comcast have just started dropping IE9 and IE10 support. So we started messaging out to our customers that we're no longer going to support those browsers. I hope everyone else follows suit. It's less than 1% of our traffic now. So it's great, IE11 above. But what happens is, as you start using these APIs and it's built into the browser, you get closer to the metal. So it becomes a lot faster for your users at your website, in your application, for the users. And that's, again, why I really love Polymer, is because their motto is all about using the platform to build a better web. And the Polymer team, we owe them a lot of thanks for taking the web component specs and working with all the other browser teams to actually get it pushed into the browser and to make these specs possible. Because if it wasn't for them constantly getting Safari, getting Firefox, getting Edge at the table to talk about these things, it would have never happened. And so the other thing is you can use web components and Polymer with these other frameworks and libraries. It doesn't mean that you have to stop using these other things or that these other frameworks and libraries aren't great, because they are. The web components are supposed to exist between the web platform and your existing frameworks so that you can sprinkle a couple on, or you can build entire applications with them. It really doesn't matter. But the other thing is, eventually, someday, React or Angular can start changing the framework to take advantage of these web component specs that are built in the browser. So they'll also be able to benefit from the performance increases that we'll see. And lastly, there are other libraries that are taking advantage of web components right now. Bosonic, Xtag, and Skate.js are just 3, which are very lightweight and very good too. So that summarizes why I love Polymer. Now we're going to go into Act 2. The Polymer experience at Comcast, of course. So I always like to start off with, we've been using Polymer for almost 3 years now. And the biggest question is why Polymer? Why did we choose Polymer? And so the story starts when our product team came to us and they asked us to build this new Xfinity Home website. And as a senior principal, I started looking up at all the different frameworks and checking out Angular and React, mostly Angular and React. And I talked to my one coworker one day. I come in and I'm like, hey, Phil, what should we do for this new site? And just to give you some idea of what type of developer Phil is, he's the one who reads all the latest blog articles, watches all the latest videos, and as soon as something's announced is in Canary, he's like, we should totally use service workers, and we should use this other thing. I'm like, Phil, nobody supports this stuff yet. But anyway, I come in and I talk to him, and he's like, we should use Google Polymer. And so I look at him like my 2-year-old, who I taught to say progressive web apps. And he understands the word progressive web apps, but he has no idea what it means. And like Theo, I had no idea what Google Polymer was. But unlike Theo, I knew how to use the internet. So I was actually able to Google it and checked it out. And I was like, wow, this stuff is actually pretty cool, this web component idea. So I did what any other senior developer, architect type person would do. I got the team together and I consulted the whiteboard and we listed out some pros and cons of why we really liked Google Polymer. The main one is it's backed by Google. They have a lot of smart developers who are really great at what they're building. It's future oriented. This was 2.5 years ago. We're just really excited now that it's paying off, that a lot of the browsers are implementing the specs, that it's going to get faster. The documentation is great. Developers love it because it's simple. It's great to write components. Some of the cons at the time were it was not even alpha. Taylor Savage said it was experimental at the Polymer Summit, and I got on his case for that. I was joking because we were probably the first large company to go to production with an experimental technology. And it had no Selenium support, testing, tooling, browser support just wasn't there yet. And so when we first decided to go along and start using Polymer, I was really nervous in the beginning. And as we continued building our application and we figured things out, I got a lot less nervous and a lot more excited about the technology and where it was going. So long story short, we did eventually finish the Xfinity home site. We deployed it out to prod. Everything works great. Each one of these little pieces that you see is its own component. We can create multiple XH lights or an XH thermostat or an XH door, and you just drop it on the page and it works. But we did learn some valuable lessons. One of the big ones is that experimental software is subject to change. We launched with the 0.56 version of Polymer. Polymer 1 was just around the corner. But luckily, the Polymer team created this PolyUp tool, which goes through all your markup, quickly changes it to the new syntax. And that's going to be really a great tool for when Polymer 2.0 comes out in the next probably month or two. Don't want to steal Polymer's thunder, but I'm really looking forward to Polymer 2. They've proven that the technology, that the web component spec is no longer experimental. It's actually really great. A lot of people are adopting it and are excited about it. And some of the new things that Polymer 2 is going to emphasize is it's going to use the custom elements v1 spec, which all the browser manufacturers have agreed to implement. It's going to be backwards compatible with Polymer 1 because they're using a hybrid mode. It's going to be much smaller in size than the Polymer v1. It's got this new data system, which is simpler to use. And they're going to support ES6 out of the box, so they'll transpile back to ES5. But really excited about it, really looking forward to what the new Polymer offers. And so now we're going to get into the Polymer architecture, how we're actually building our sites at Comcast. And I want to talk about our latest site. So this is the X-Fi site, and again, allows users to control their internet. But this site is completely static. It's great. I'm going to start off with talking about our server architecture and how we actually host this new site. And in order to do that, I have to talk about how we previously used to host our sites. And so, sorry, I know this is a diagram, a flow chart, but before, what would happen is the browser would make a request to internet.xfinity.com, which would hit our CDN. We have a GSLB for disaster, so we have servers on the West Coast, servers on the East Coast, which then we'd have a whole bunch of Ruby on Rails servers serving our application. And the reason for that was the browser, the user had to log in. And in order to log in, they would request an access token from our login server, which is another site. And that server would return a token to the browser. And the browser would then send that token to our Ruby on Rails layer. Let me get my little pointer here. It would send the token to our Ruby on Rails layer. It would make a back-end call to our login server to get the access token and then store it on our Ruby on Rails server. And then the browser would be able to make API calls proxied through our Ruby on Rails, which would then call the API and return the data back to the browser. And so, I spent a long time simplifying that, almost a year. And so our new architecture is very similar to the previous. Now when you go to internet.xfinity.com, it hits our CDN, which is again GSLB'd to 2 Nginx servers. So we actually eliminated, we used to have like 16 Ruby on Rails servers because it would have to handle all this traffic of API calls. And now we're actually just doing 2 Nginx servers because our entire site is completely static. And what happens is when a user logs in now, they call our login server, and the login server returns the access token directly to the browser. And this is called implicit OAuth. And you need to have SSL in order for this to work. But it sends the access token directly back to the browser, and we get it via JavaScript. And so we no longer have this Ruby on Rails layer needing to make token calls to the server. And the other great part is now when the browser wants to make an API request, it actually calls the API directly. There's no proxy layer happening in between because we're using CORS. And for those not familiar with CORS, it stands for Cross-Origin Resource Sharing. I think I got that right. And essentially, our site is hosted at internet.xfinity.com, but we're making API calls to siorg.xfinity.com. And that's a cross-domain request, and we're adding the access token onto the request for authentication. And that gives us our data back that we need to render our site. But there's some great benefits for separating out your front end from your API. And for us, we have big teams. Maybe you don't have big teams, but we have 15 front end developers and probably 10 API developers. But on the front end now, we have no load testing requirements. We have no downtime. Nobody's getting called in the middle of the night because it's completely static. We didn't mess anything up. They call the API guys, which is great for us. And we can deploy our entire site in less than 5 minutes. It's just a matter of how long it takes to actually transmit our static assets up to the server. And when you do this, we now simplified by decoupling our site from our API. All right, so now that we got past the server architecture, I want to talk a little bit more about how we actually write our Polymer apps. And the first thing that we follow is the purple pattern. You've probably heard this before from Google. And I'm reading from my notes, but it stands for push critical resources for the initial route, render the initial route, pre-cache the remaining routes, and then lazy load and create remaining routes on demand. And so the Polymer team has this app shell architecture diagram. And what they're basically showing is you have your index page, so the user comes to the main page, and in there you have your My App shell, which is your main container Polymer component. And that loads and shows the initial page, and when that loads, it also loads in these additional fragments. And I saw this and I'm like, it's good, but we can do better. And when you look at what happens in the developer tools when an application loads, you have almost a second of initializing all these Polymer components. And the Polymer components have to initialize before they actually do anything. And this is a problem. And what happened when we first started doing Polymer, we used to believe that everything should be a component. We drank the Kool-Aid and everything should be a component, and all your data stuff should be components, etc. And now we've realized that you don't want to do this. That is not what you want to do at all. You have to remember that web components are just another tool in your toolbox. And eventually we're going to need a big truck to hold all the tools that we have in our toolbox because there's new frameworks and libraries happening all the time. But that's besides the point. So getting back to what was happening on our site, our critical path was the users coming in, they need to authenticate, and then we need to start making API calls as quickly as possible, because some of the API calls would actually take a second or two to come back with actual data, and the site isn't useful until we get that information back. And then we actually want to load the views and show something to the user. Well, show something and load the views in the back end or in the background. And so our index page looks more like this, where in just plain old JavaScript, vanilla JavaScript, we're getting the access token as soon as the page loads. And then we have a Redux data store, which is initializing and starting to make API calls. And at the same time that that's happening, we're loading in, we have two shared vanilla components that I'll talk about later. We have our main XC app container, which is initializing the site and the views at the same time that all of our data is being loaded in the background. And we also are using the app shell architecture that Polymer talked about. So our XC app loads, and then it downloads the additional fragments for the other pages that we have. And so now I want to talk a little bit about unidirectional data flow with Redux. We are using Redux in some of our sites. And the reason for this is it's a good way to decouple your state from your UI. The unidirectional data flow also simplifies structuring your apps, which we're going to talk about in more detail. The loadable state is great because you can actually have your customers, if they have a problem, they can send you their store and you can know exactly how they got there. So really great for debugging or showing us a specific scenario for testing, etc. And it's also been around for a while, so there's great developer tools to make it a lot easier to use Redux. So again, this is what happens. Our index page loads in just plain old vanilla JavaScript. Really want to emphasize the vanilla JavaScript. Our Redux store starts. We have the smart parent, which we'll talk about in a second, but the store is passed into our XC app container, and our app container is responsible for giving state to each one of these views, the people page, devices, and settings page. And all your business logic should be contained in this smart parent, and it completely separates out your views from the business logic. So here we have the people page receiving state from its parent. And again, this thing is just a dumb child or a stateless child, whichever word you want to use for it. And what happens is when a user clicks on unpause all devices or clicks on one of these elements, that fires off a native event, XC people unpause all devices. And like a child, again, this is my son, Theo, he says, "What's that?" He doesn't know what to do. What happens is, my son always points at stuff and says, "What's that? What's that?" He doesn't know. And what happens, he has to ask his smart parent. He says, "What should I do, Dad?" And it's the responsibility of the smart parent to figure out what exactly to do. And so for us, we have the smart parent starts up outside of XC app and adds all these listeners to XC app. So it's going to listen for XC people unpause all devices and translate that into an action creator. So all the actions are unpause all devices, etc. You can have a whole lot more actions. And all you're doing is looping through all your events and adding them to XC app for native event listeners. So again, what happens is the people view, they clicked on a button, native event fires up, XC app gets it, which goes into smart parent, and the smart parent, is responsible for then following the Redux flow, which is an action happened, it's going to dispatch an event to the store, which is going to reduce it, which is going to update the state and pass that back down to the view. So saying the same thing again, native event comes into the smart parent. It's going to perform all the business logic that we need, make API calls. So for instance, we can set the state to fetch started, fetch completed, devices enabled, which goes into the store, updates the state, which updates the view. So the view got a new updated state, changed the button to pause all devices, and it's really great to use Redux to separate out your state from your UI. If you want more information on how to use Redux and Polymer, Rob Dotson actually has 2 videos now. The first one is how to use Redux and Polymer. He just released Polycast 62 yesterday, which goes into more detail about asynchronous actions. So certainly check them out. But again, if you follow this pattern, you're decoupling your state from your UI. So all your business logic is kept in its own place, and you really simplify your UI. And the other great benefit is if you can pull out all your business logic outside of your app, you can actually take that business logic and use it on React Native or on the website. Because we have scenarios in our company where we build native applications on mobile phones, and we want to figure out how to reuse a lot of the business logic that we're using on the web already. All right. So now I want to talk about how we actually develop new features in Comcast. And as I mentioned, we have a lot of developers on a single project. This is actually a small amount, or not the full amount, that are on the front end. And so if we get a new feature like the people page, using web components, it's really great because we can break it up into one developer is responsible for updating the state and updating the Redux store to present the state needed for this view. We can have another developer responsible for building the entire page or the main level component. And you can have another developer responsible for building this little chart widget and component. And you can have another developer responsible for doing this access rules component. And that's really powerful because as soon as you can break stuff down into smaller pieces, developers are really able to focus on the task at hand. And we also practice the notion of DDD. And DDD stands for Demo-Driven Development. And what that means is our developers who are given these tasks are focused on building that one piece. And when they're completed that feature, they actually have to produce a demo page, which is completely independent from the rest of the site and has to work by itself. And that really decouples that one component from all the other pieces. And that demo page can contain all the different states. So this is actually an index page that you can scroll down and see all the different states. But you have an individual working component. And the other great part is our components, if you follow this Polymer paradigm, SI page owner is a folder which has a demo of an index page which shows exactly how to use that component. And it also contains its tests right with it. So you can run all the tests in the browser at the same time that you're looking at the demo page. And we can write individual tests to make sure that our components are working well. And this is really powerful because, again, Polymer is designed with a set of principles in mind: encapsulation, composition, and separation of concerns. So you have to remember that when you're building your components, your components need to live by themselves. All right. Oop, went too far. So I want to talk a little bit about how we actually write our code and what our development environment looks like. And the first piece is, we use an editor. This is actually Atom. I'm currently using VS Code. VS Code is really good, and there's actually a Polymer plugin for VS Code, which makes it easy to do snippets and stuff. We're also using the Polymer CLI, not necessarily the Polymer CLI, but a lot of the build tools that make up the Polymer CLI. If you're working on a smaller site or if you want to get started, the Polymer CLI is great. You can just do Polymer init and create an application. And it has all the build tools built in. And then we're also using the Chrome web browser. You can use Firefox if you want. Chrome is great. But you'll notice we're not using any jQuery. We prefer to use vanilla.js, which is much faster than jQuery. We're currently not doing any pre-processing. We don't have Babel in place. And we're also not using Sass because the latest platform specials are CSS variables and apply, which allows you to do a lot of what Sass does. Sass is pretty great. I'm not dissing Sass, but a lot of the platform stuff that's coming up is actually making it a lot easier to do it without these other tools that have been built for it. So other things that we're taking advantage of, this again is use the platform. This has no relation to Polymer. You can use this without Polymer. Fetch is like the new $.ajax. Promises, if you're not using promises or don't know what promises are, definitely check out my other talk. You definitely need to know promises, especially with ES6. It's all about promises. But it basically is like placing an order at a fast food place for a burger, and eventually it will get resolved with either you'll get the burger or you'll have an error, and then you have to catch it and say, oh no, get me fries or something else instead. And CORS, again, allows you to make cross-origin requests, and it's a great way of separating out your API from your UI. All right, we've reached Act 3, which I like to call vanilla components. I actually spent some time writing a vanilla component outside of Polymer, and that component is this Polaris navigation that we call it Polaris. This is a universal header that we share across all of our sites. And there's also a universal footer, which we'll check in a second. But for us internally, Polaris was our elephant. This thing was a Ruby on Rails application which talked to a CMS, which has been around for many years and has really gotten bloated over time and way too many features. So I set out with this goals of rewriting this with small size. I wanted it to be really fast, and I wanted it to be really simple for third parties to use it. And so in order to do it, I actually just created a custom element. And to load the custom element, you actually just load the script tag, and you can load it asynchronously. Again, I'm avoiding HTML imports because most of the browsers don't seem like they're going to implement that, and it's a lot of overhead to polyfill that. So you can easily do it with just a script tag. And when you load the script tag, you actually can just use the custom element like you would any normal element. So XC header, and then it has certain attributes that you can use to customize the header. And the same thing, that same script tag also includes another custom element, XC footer. So you can put multiple custom elements in one script tag, and it's really great. But I learned a lot of lessons doing this, or I had to first figure out a build process because I wasn't using Polymer and I wanted to avoid HTML imports. I had to get some tools together which would take the HTML, I wrote it in a separate HTML file. So I used Node to grab all the HTML, compress it down into a string, and then put it into my script file. The other problem was IE11 doesn't support the class syntax, which you need for custom elements v1. So I had to use Babel out of the box just to convert it so that IE11 would support it. I'm using EJS templates to do quick little HTML builds. I did use Sass. I actually do like Sass because I wasn't going to polyfill CSS variables. But I spent a lot of time learning a bunch of tools in order for this to happen. The other thing, custom elements v1, I really like it. The new class syntax is great except for IE11. I had to figure out how to inject the style markups. So I actually have the CSS file separately from the HTML files. And during the build process, I actually go through, grab it, compress it down into a string, and inject it into my script so that I can load this all as just a single script tag. And then I inner HTML that into the page that loads it. So the only polyfill that I'm also using for custom elements v1, I'm using the official web components one, which is also currently being rewritten and finished up. I'm looking forward to that getting done. But the other challenge I faced was like there's not many examples of using custom elements v1 yet. It's still pretty new. So some of the lessons that I learned, or some key takeaway, is you definitely want to use a framework or a library such as Polymer or Skate.js unless you really want small file size, which is one of the things that I wanted. Because frameworks and libraries save a lot of time. It takes a whole heck of a lot of time to get all the plumbing in place to make this stuff happen. And these libraries and frameworks are made so that it's very easy to get started, and they take care of the majority of your problems as long as you, again, follow their path. So just to wrap everything up, I really want everyone to take away, decouple all the things. It's really important that you do that because simplicity matters. You don't want to have a huge elephant as your application that you have to maintain. And during his talk, he also emphasizes that simple does not necessarily mean easy. It's actually really hard to make things simple and keep things simple. So for instance, for me to do that implicit OAuth in the server architecture that I talked about earlier, that took me a full year to figure it out, to get security to approve implicit OAuth, to write a JavaScript library to do that. It's really hard. And also our CDN Nginx architecture took me 6 months to figure out how to do that, get Cloud Foundry set up and do all this stuff to do a new deployment flow. It took a really long time. And I want other developers to really know, sometimes you have to take on these challenges and you have to step up in your organization, and you see these big problems and you can't just be like, oh, I'll fix it later or I'll do it now. You have to invest the time. You have to realize you're going to be there, if you're going to be there for a long time, to take up the mantle, right? And yeah, it's going to take you a year, and not maybe your full attention, but definitely some of your attention. And some problems actually take a while of just chipping away at it and chipping away at it. But if you do that and you take on these challenges, you have to remember that simplicity creates opportunity. And when you can create really simple things, it means you'll be much more nimble and you'll be, just like Rocky, an awesome, awesome developer. So thank you all for taking the time to listen to this. More than happy to take on questions now. And that's it for me.
Thank you very much, Chris. That was incredibly fascinating. I see a lot of chatter in the chat going on, and
a lot of chatter in the chat.
A lot of chatter in the chat. That's very difficult to say, though it was very early when I started this morning, so it's all hit or miss here on the Pacific Coast. So we got a couple questions.
Great.
Could you elaborate on the importance of making the Smart Parent state store a component?
Yeah, so essentially you can have it as a Polymer component or some data component but the important part is just separating it out from your views. So you really don't want your individual pages doing any business logic. You want to try to push that off into a component or one single component that is doing it, because it makes it a lot easier for you to reuse that component in other places. One of the things that we're working on at Comcast is we have a lot of different websites, and one website is for your home components and automation, and another one is for controlling your Wi-Fi. And they're separate APIs, but we want to get to the point where all that business logic can be shared between multiple sites. So regardless of what site you're on, you can get that information and easily implement a view which takes advantage of some of that logic. So I hope that makes sense. And you can also check out Home Assistant IO if you want more information on it, and I'll link it in the chat in a second. But this is a great open source project which gives you examples of doing some of the things that I just talked about.
home-assistant.io for those of you who can't see the chat at the moment.
Yeah, and that actually is written with Google Polymer as well. So they built their whole view on that.
I'm a fan of Polymer. I think most people who've listened to me on the Web Platform podcast know this. And there's actually an interesting question in regards to HTML imports, because as someone who uses Polymer, HTML imports kind of comes with the notion of a component. But if you're avoiding HTML imports, how are you doing something similar to what Vulcanize does to sort of deduplicate your dependencies?
Yeah, so for our main Polymer projects, we're using HTML imports. And it's kind of a shame in some regards, is that a lot of the browser manufacturers or developers are not going to be implementing it. They're waiting for what's going to happen with ES6 module imports. And the big problem is it's like a 20 kilobyte polyfill, I think, for HTML imports. So you have to pay that cost for browsers that aren't using it. And then we are vulcanizing all our assets. So you're really only using HTML imports one time, maybe 3 times if you have multiple different fragments. So it's a really small amount of use to have to include this huge polyfill for it. And so when I did that vanilla component, I wanted to avoid it because, again, our main portal is not using Polymer, so I didn't want to have to polyfill that. And it took a while to figure out how to inject it all to just be a script tag and then import it, or just load the script tag. But it was well worth it because that whole header and footer is 12 kilobytes for the entire thing. So it's a very small package and very fast.
Well, when it comes to download size, I think a lot of people have a tendency to forget that, particularly when you have to spin up so much JavaScript and everything else that goes with it. When you see a lot of frameworks sort of pile on, to your example in your talk, the idea of using Angular for a single page that could be coupled and static. And along those lines, were you ever tempted to switch to React? This is a question that just came in from Rob Stone for the view, since you mentioned using React Native. If you did sort of weigh that option, why did you choose to stick with Polymer?
Again, the big thing for me is I've been a web developer for 16 years. So I've existed before all these frameworks came out, and I really knew how to write vanilla web components or vanilla sites, I would say. And so we did play around with React, and I do like React. I don't want to downplay like the fact that these other libraries are really awesome. But for me, the big sell for web components was the fact that these are going to be built into the browser. They are automatically going to be faster. And a lot of the things that these frameworks are doing is giving you the structure to build components, which if the browser is going to give you that structure anyway, why do you really need these other frameworks anymore? So that was kind of my thing. And I never really liked the JSX syntax and all that pre-processing. And again, you know, as I talked about in the beginning, is you get these developers who are know React, and they don't spend any time understanding what React is doing to convert that to what the browser is seeing. And they don't understand what's happening at the browser level. And that becomes very concerning when you have to debug problems that the browser is experiencing. So.
Yeah, it can be very difficult. I mean, there is quite a bit of debate, you know, I know amongst people who are sort of trying to teach people, you know, sort of the fundamentals of the web today. And that comes up a lot now, which is how do you start out? You know, with a lot of people, frameworks are easy to spin up.
Oh, yeah.
You know, learning the platform is a little bit more difficult if, especially, and I always get a lot of questions myself, in terms of, hey, why does this exist as an API in the platform? Well, 20 years ago, and then you go back into the historicals of, sort of how the web sort of evolved. So there's a lot of interesting things there, but at the same time, there are definitely trade-offs.
I keep going back to that slide. It's hard, and I want other developers to know, like, the web platform is extremely hard. There's so much happening. Even as a principal engineer, been doing this for a really long time, I struggle with keeping up with all the changes that are happening and staying on the cutting edge and just understanding what's going on. I'm sorry if you're just coming to this field now. I think that's a lot of problems that we have is new developers who want to build something on the web. They Google it and they're like, how do I build something for the web? And they get Angular, and then they go and like, well, let me implement it in Angular, because that's all they know. And, it's tough. You really need someone who's been doing it for a while to join the team, to help out in the beginning, to set things up right, and build up these new developers.
So we got another question that just came in from Daz. They ask, how do you sell the prospect of writing or rewriting these sorts of systems internally to management? I know this is a question that I get a lot as well. How do you demonstrate that these things have business benefits in terms of the things that they do?
Whew, that is a great question. Our business team right now is all about reusability, right? And that's the big sell. It's like once you write one of these components and you can reuse it anywhere, huge win. One of the things that our business product teams have always wanted is being able to take like your home security status and drop it on the main portal. And we're selling this to them as like, hey, if we start writing these small components that are reusable everywhere, we can write it once and just drop it in other places. And that's really the great benefit of these components is you want to keep things really small, because when business asks you to, hey, drop that from this one place to this other place, you can do it. And that's why, I try to avoid Angular and React, because we have sites at our company which are in Angular, and then we get the question of, well, how do we take that Angular component and drop it on the Polymer site? And it's like, you can't do that because it's Angular, and then we have to implement Angular. But you can do it the other way. You can take a web component and drop it in other places. So, and I wouldn't emphasize like taking your current site and rewriting it into something else. Like you need business value to have that. But the big thing is, if you start writing your new stuff, your new features as components, you can do that with your current site. But it gives you the benefit, again, of having your small pieces that you can reuse in other places. And it's really only valuable if you're in a really large organization where you get a lot of benefit from reusability. But the other great benefit with using Polymer is they have so many free components that you can just use them and build up a site very quickly with material design that just rocks. So totally love Polymer. Thank you again, Polymer. I love you guys.
And the ecosystem's growing. Webcomponents.org just relaunched, and there's a lot of more components sort of coming across the way. Do take a look at collections if you haven't visited webcomponents.org. And we're running up against time, but Chris, thank you so much for coming out today and speaking here on Web Components Remote Conf.
Thank you for having me, and thank you for putting on the conference. I'm really excited for the rest of the talks, too.
So if you're out there on the live stream, we're about to head into a break. So this is that moment in time where you hit the lavatory, find yourself some coffee and a snack, and then head back for another series of 5 or 6 talks that we have in the afternoon that are going to be absolutely fantastic. So we're going to sign off here for about 30 minutes, and then we'll be back with more talks here at Web Components Remote Conf.
Thank you.